Okay, we're going to start at number 12. How many groups and periods are on the periodic table? Write this down. Knowing this information, you should be able to answer that question. I'll find the groups for you, but you're going to be on your own for the periods. So it says groups are the ones that are going down. Okay, so if I look at the periodic table, I'm literally going to have to count going down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, 18 groups. Groups, because groups go down. Groups are the ones that go down. You guys can find periods. They're the ones that are going horizontal. You just look at the periodic table and count. Number 12. Would elements share similar behavior and properties? Are they in the same group or period? Yes, they are in the same group. Good job, whoever said that. Okay, so just like all the noble gases at the very end, they all behave the same. All of these are noble gases, and they are all inert. They do not react. So the ones that are in the same columns are going to have similar behavior. 13. Explain the location of metals and nonmetals in the periodic table in relation to the dark staircase line. The dark staircase line is right here. So everything to the right of this, and you can even start making your own periodic table now if you want. These are nonmetals. Everything else, metals. Okay, that's the way the periodic table is separated, and you need to know that to figure out ionic and covalent bonds, which we're going to be getting to next. But everything to the right of the staircase, nonmetals. Everything else is metals. So you can write that for number 13. Number 14, the electron configuration of aluminum, atomic number 13 is, and they give it to us. Aluminum is in period what? Yes, that is correct. Here's period 1, period 2, period 3. Remember, periods are the ones lying horizontal. The elements whose electron configurations end with sp or s2p5 belong to what group? Okay, so it's s2p5. A way you can figure out what elements these are really fast, or where your finger's going to stop, is just to add these little exponents. Well, per group. So let's go with P. I'll show you what I mean. Okay, so it's S2. So this is the S group. Just these first two. That's why S only goes up to 2. So you go 1, 2 for the S's because the exponent was 2. And then over here is the P block. And for P's, it tells you to go 5 blocks. 1, 2, 3, 4, 5. So I stop in what group? What group number? 17. And those are also in group 17. If you're kind of marking up your periodic table to get it ready for the final, these are called halogens. So halogens are in group 17. You can call those salts. 18 are noble gases. Okay, 16, you have to do it for each. You have to find the largest atomic radius in each group, like for A, for B, for C. So if we're looking at A, the pattern or trend for atomic radius is if you go this way to the left and down. Oh, oops. Okay, let me skip this over. So if you go left and down, radius increases. So if we look at F-O-N or F-N-O. It doesn't matter. On the periodic table, F-O-N. Okay, so we're looking at this, this, and this. And the pattern, like I said, is they get larger as you go this way. For radius only. Okay, so for F-O-N, which has the largest atomic radius? Anyone? N. N would have the largest radius because it's the most left. Okay, so I'm just going to write radius increasing as you move to the left of the periodic table. What if it was F-O-B? What would have the largest radius? B. Okay, so we understand that. So I did A for you. You are going to be responsible for B. I just taught you how to figure it out. And C. So when you guys bring it up, I'm going to be checking to see if you did B and C. And also up here on number 12, you needed to write that one. I'm going to do it in a different color so you know. Probably pink. No, a different color. Blue. Okay, so now let's look at the electronegativity. I'm on number 17. Again, you need to do it for each A, B, and C. So the pattern for electronegativity is if you go up and to the right. So it's doing the exact opposite. If you go up and to the right, electronegativity increases. So let's look at FCO. It's in the same line. Okay, but the pattern for electronegativity is this way. So out of C, O, and F, which one has the strongest electronegativity? F. F has the strongest. For electronegativity, as you go to the right and up, electronegativity increases. So what if I said what has the strongest electronegativity? Cl or Ne? Ne has a stronger electronegativity because it's more up and to the right. Okay. So this has the strongest electronegativity, F, out of that subgroup. So you guys are going to be responsible for B and C. There's the pattern. If I had my cheat sheet out, I would write down the trends for all of them. Okay, I would write down that one, and I would write down that for radius. Place the following elements in order of increasing electronegativity. Okay, magnesium, sulfur, fluorine, cesium, and boron. Increasing electronegativity. I'm going to put a little dot on these so we can see them. Magnesium, sulfur, fluorine, cesium. So these are all spread out. Yeah, this is one you guys, I think, would benefit from doing on your own. I'll leave it there. It's hard to see on the screen because cesium's way over here. Keep in mind that the pattern for electronegativity, it's as you go up and to the right. So cesium is probably not going to be the strongest electronegativity. The strongest electronegativity is going to be whichever one's at the highest and all the way to the right. And it looks like that's going to be fluorine. So I just gave you your lowest and your highest, and you guys can figure out the other three. There, and magnesium's on the other side. So pay attention to that one. When you guys bring it up, I'm going to grade 18. Okay, so if you're not sure what I'm going to look at, I circled it. I'm going to look at number 12 where it says periods. I am going to look at 16B and C, 17B and C, and 18 thus far. Okay, let's take a look at number 19. These are trends and patterns you need to know. So for electronegativity, the pattern is some students like going like that. It's as you go up and to the right. Ionization, it's the same thing. Up and to the right. Atomic radius, it is down and this way. Okay, so now we're getting into Lewis dot structures. That's when you put dots around the element. So let's take a look at the periodic table. It wants the dot structure for phosphorus. Okay, these numbers in blue that are written for you, those are valence electrons. Okay, this is a 3. You need to know valence electrons for the final or you won't know how to do the Lewis dot structure. So I would probably write that down on my periodic table. If anything falls in this column, it's going to have 7 dots around it. 6 dots, 5 dots, 4 dots, 3 dots, 2 dots, 1 dot on the other side. Okay, so it asks for phosphorus, so you have to look for P, which is right here. How many dots should it have? 5 dots. So here's my phosphorus, and there's 5 dots. 1, 2, 3, 4, 5. How many electron pairs are there? That's the first question. How many is a pair? 1. It's just these two. I know they're kind of close to each other. But there's 2 up there as a pair. So it would be 1. And then how many of them are unpaired?
3.
Yep, and that would go there. Number 21, which of the following correctly matches a compound with its molecular geometry? So these were difficult to remember. You can write down the most common ones. That might help you. We'll start with process of elimination with A. Is water linear?
No.
What is it?
Bent.
Yes, perfect. It's bent. You guys need to remember that water is polar. It's not in a straight line. They kind of separate from each other. So water is, I'm going to kind of write it at the top. Okay. So it's bent like that. So no. Carbon dioxide. Tetrahedral. Tetra means 4. Okay, so if you look at CO2, does this take a shape of like 4 arms anywhere? No. I mean, you'd have to, that's not the correct Lewis structure, but it can't be tetra. Okay, so now you're down to 2 of them. Depending on the method, how you remember these, I always count the number of atoms and subtract 1, and that's the prefix. So this has 3 hydrogens and 1 nitrogen. So that gives me 4 total atoms. And then I subtract 1 and it's 3 and it matches trigonal. Tri meaning 3. So that's one way you can pair it up unless you remember how to draw them specifically. The correct answer is C. Number 22, I just told you about the valence electrons, so you can go ahead and do that on your own. So 22 I'm going to be grading you on when you come up. 24 I'm going to be grading you. So the ones I'm grading you guys on, when I look at your review before you leave, it's because I already taught it to you. Like right now I just taught you how to do it.
Wait, so do we do 22 after?
Yes. And what time is it? 9:13. We'll go ahead and stop here. I'm going to do 25 with you guys, so don't bother with that one. I'm going to have you